Hi guys, welcome to Vedant Education. Today I have one more problem for you from GATE 2014 set 4, and here is the question. Given f is equal to zax plus xay cap plus yaz cap, if S represents the portion of a sphere x square plus y square plus z square equal to 1 for z greater than or equal to 0, then the value of the integral surface integral curl of f dot ds is. So we have to solve this integral and find the value of this integral. Before we do that, if you have not subscribed to our channel, please go ahead and subscribe to our channel. Okay, so to find the value of this integral, first I will just write it down. So it is curl of, it is a surface integral of curl of f dot ds. Now from this integral we have to realize that this question is based on Stokes theorem, and Stokes theorem is one of the important topics in GATE electronics and communication, and this question is based on that. From the Stokes theorem, so we have to realize that this question is based on Stokes theorem. So Stokes theorem states that the surface integral of curl of f over a surface can also be given as a closed line integral, which is it's a line integral of f dot dr over that line. So this is the Stokes theorem, and given is a surface which is portion of a sphere. So if we just assume this, if we just have a schematic of this sphere, so if you say this, the hemisphere which is located is greater than z greater than or equal to 0, and if we say that this here is x and this is y, so the axis, so what we have here is this is z. So we have here is a hemispherical surface which is covering for values z greater than or equal to 0. Now in order to find the value of this integral, we can also solve the same, we can also find the same value by solving this integral here, and this is much easier to solve than this surface integral here, and for this one we only need to integrate along this line here, this line of the surface, and get the value of this surface integral. So let's just write down, let's just draw another schematic to see how the line integral of this will look. So if we have if we just rotate it around this surface, so what we have is x and y, and we have a circle over which we have to integrate. So we know from the given equation, we know that this this circle is x square plus y square equal to 1, and since z is equal to 0. So we have this vector here, so let's just call it r, and then we have x component and the y component, and this angle, let's say it's theta. Now we have this schematic. From this, let's just convert the convert this problem into one that of a spherical coordinate. So first what I will do is I will write f dot dr in spherical coordinates. So what we have here is, so from this we can write that x is equal to r cos theta and y is equal to r sin theta. but the radius r is equal to 1. So, x is equal to cos theta. So, we can just write x equal to cos theta and y is equal to sin theta. Now, let us just write this vector, two vectors in terms of cos and sin theta. So, we have f equal to z, which is 0 in this case. So, 0 ax cap plus x. So, x is just cos theta ay cap plus y is sin theta az cap, and r, the vector r is x ax cap plus y ay cap, and z is 0 anyway. So, 0 is it cap. So, r can all be written as cos theta ax cap plus sin theta ay cap. Now, let us just find out what is the differentiation what is the dr vector. So, it is minus sin theta ax cap plus cos theta ay cap, and we have d theta outside. So, now we have this vector and the dr vector together. So, let us just find what is f dot dr. So, if you just say so, f dot dr is given as, so 0 and 0 cancel out. So, it is a cos square theta ay. So, cos square theta ay is just 1, and sin theta az, this is also 0. So, it is a cos square theta d theta. Now, the value of the line integral from cos square theta d theta. So, this is 0 to, so this circle is going from 0 to 2 pi whole circle. So, it is 0 to 2 pi cos square theta d theta, which is this is a quite a simple integral to solve, and I just know the integration value for here. So, it is 1, it is theta by 2 plus sine 2 theta by 4, varying from 0 to 2 pi, and this gives the total integral f dot dr over this curve as so this is 0 and this will be 2 pi by 2. So, it is pi. So, the value of this integral of this surface integral curl of f dot ds is pi. Thanks for watching. Please subscribe to our channel and check out the description below for books that I recommend for studying GATE.